Okay, so the next thing we're going to talk about are the trigonometric functions and their reciprocals. Okay, so your trig functions are made of trig ratios. Please make sure your earbuds are out and your phones are not visible, please, not on your desk, but in a pocket or a bag. Okay, so a trig ratio is going to compare the lengths of two sides of a right triangle. So we are going to be working with right triangles today. And a trig function is going to relate the angles of a triangle to its sides. Yeah, okay, okay, so a trig function relates the angles of a triangle to the length of the sides. Okay, so the first function we're going to talk about is sine. It is pronounced sine, not sin. I put the pronunciations here in parentheses for us. So when you're doing the sine of, this is our theta value, the sine of theta is equal to the opposite over, do you guys remember? Hypotenuse. If you don't remember, it is down here. Okay, and then the cosine of theta is equal to the adjacent over the hypotenuse. And then the tangent, or what you call a man at the beach, is the opposite over the adjacent. What do you call a man at the beach? A tangent.
Oh.
I saw it in a math book and I just loved it.
Like the gentleman.
Like, yeah, gentleman. A gent. Gentleman. Yes.
Oh, I get it now.
Okay, so the sine is part of your SOHCAHTOA. Okay, so the sine is the opposite side over the hypotenuse. That's what makes the SO in the SOHCAHTOA. The ka, which I always think of as the Boston accent, right? Go past the ka. Yeah, that's, for some reason, that's always what it reminds me of. Is the adjacent over the hypotenuse. And then a man at the beach is going to be opposite over adjacent. Okay, so I know some of you guys are going to remember this from geometry. Some of you might need more of a review. So we do have this key concept figure here. When we are writing out sine, cosine, and tangent, we are going to be using theta or some other type of angle measure. So it might be a variable or it could be theta. When you are writing these out, and you are using the opposite, the adjacent, and the hypotenuse, remember that the hypotenuse can always be found because it is located across from the right angle. Okay, the hypotenuse is also the longest side, but sometimes we don't have triangles that are drawn to scale, which is why we always want to locate the side that is across from the right angle, and then from there we can find the adjacent leg. Do you guys remember what adjacent means? Yeah, next to. So it is next to the angle, or it creates the angle. The opposite side does not touch that angle. So in this case, we have our value of theta, okay, right here. So everything goes from that given angle. Okay, so we have our trig functions, the sine, cosine, and tangent. We do work with those the most often, but we also have what are called the reciprocal functions. So remember, whenever you have a fraction, if you're making the reciprocal, what do you do to that fraction? Yep, you just flip it. So that's exactly what happens with our reciprocals. Okay, so cosecant, secant, cotangent. Okay, and so you are just going to flip those. So it's H over O, it is H over A, it is A over O. Okay, so it doesn't have a cool thing like SOHCAHTOA, but sometimes I like to say it's ho, ha, ayo. That's not how I remember it though, I just do the flip. You don't like it?
I don't like that.
Oh, okay, so when you are working with these, okay, everybody remembers tangent and cotangent because the tangent is in the word, and then people tend to get a little bit confused with these two. So what I remember is if it starts with an S, it has to have the one that starts with a C. So it's sine, and then this is called the cosecant, this is cosine, and then this is the secant. And I don't know why those are named the way they are, but I'm here to help you learn them. So the other thing we have to remember today is the Pythagorean theorem. Do we remember it? Yes, a squared plus b squared equals c squared. Okay, so when we're doing a squared plus b squared equals c squared, we just want to keep in mind that a and b are the legs and c is the hypotenuse. It really doesn't matter what order you put the legs in. But C does have to be the hypotenuse. So we're going to draw a picture below representing the Pythagorean theorem. So you can draw any right triangle you want. Commonly we see this guy. I'm not doing this shot. Now I'm making it worse. New triangle. Okay, so it does not matter which one you call A and B. Did I just label that A? Okay, and so don't put the A there. Your A can be this side or it can be this side. We're going to label it A, B, C. And I don't have my white out, so we're going to have this side. Okay, so this is our Pythagorean theorem. Okay, we have the hypotenuse, and the leg. So it does not matter which one is A and which one is B. Those are interchangeable. It really depends on what you label this. So generally when this is labeled, you guys might remember this from geometry. If this was A, uppercase A, lowercase a was across from it, do you guys remember that? And then if you had B here, lowercase b was across from it. You guys did do this. You had it when you had the law of signs. Okay, and when we start solving, we will set up a similar triangle there. Okay, so example 1 says, find the exact values of the 6 trigonometric functions for the angle theta. When you are writing out these trig functions, you've got to put the theta in. Okay, I won't give you full credit without it. And then when you are leaving your answer, and if it's a fraction, it's got to be in the simplest form. So the first thing we're going to do is look at the picture and find where theta is located. Okay, so what angle given in the diagram is theta, and we're going to label from that point. So if this is theta, okay, then 6 is the opposite side. There are 2 sides that are adjacent, which is why I generally write down the hypotenuse first. Okay, and then what we're going to do is find the sine, the cosine, the tangent, and the reciprocals. Okay, so can you guys find the sine, the cosine, and the tangent in simplest form? trigger Sokotoa. Okay, so for a sine, we're going to do opposite over hypotenuse. 2 goes into both, so we are going to divide by 2 to get 3/5. So that is going to be your sine of theta. Okay, for cosine, we're doing adjacent over hypotenuse, 8 over 10. 2 goes into both of those, so if you reduce, you will get 4/5 equals the cosine of theta. And then tangent, you have opposite over adjacent, which is going to reduce to 3/4. Okay, and then we're going to find the reciprocal function. So the reciprocal functions, once you reduce these, you can just use the reciprocal. So for the cosecant of theta, we're just going to flip it. So 5/3. The secant is the reciprocal of cosine, so 5/4. And the cotangent is the reciprocal of tangent, so we have 4/3. Okay, so once you have that and you are looking at part B of this example, I want you to notice what is different about part B. And think about what you need to do in order to find the trig functions. Okay, so flip it over to look at part B. Okay, how is this different from part A? Okay, so yeah, it has the square root, and this triangle should have yeah, and you don't have a value, right? Your triangle should have the right angle symbol on it. Okay, so we have a square root, we're missing one of the leg lengths, and we also have theta in a new position here. Okay, so if we're missing one of the leg lengths, all we have to do is use what? Yep, so this was our A, this was our B, so we're going to find B using the Pythagorean theorem. So we know A squared plus B squared equals C squared. Again, we're doing this part without our calculator, so 3 squared plus B squared equals 3√10 squared. Okay, so we have 9 plus B squared is equal to, and then let's think about how we're going to do 3√10 squared. Yeah, you remember? Yeah, so 3 squared is 9, √10 squared is 10, and then you just multiply them. Excellent. Okay, so then we know 9 times 10 is going to be 90, so we're going to subtract 9 from both sides. We have B squared is equal to 81. When we take the square root, we usually write down that plus or minus. Remember, when you are dealing with an actual length, you are going to reject the negative. Okay, so it's positive because it is a length, so your B value is going to be 9. From there, let's set up our sine of theta. So our sine of theta is opposite over hypotenuse. I find it helpful for me to label. So I find my right angle, I label this as the hypotenuse. Okay, the adjacent is next to theta, so this is now the adjacent side. And this is the opposite side. So I'm going to have 3 over 3√10. Remember, when you are in simplest form, what can't we have? Right, you can't have a square root in the denominator, so we are going to have to simplify. Notice here you also have a 3 divided by 3, which is what number? 1. So this just becomes a 1. And then to rationalize, we multiply by root 10 over root 10. Okay, so then we will have the sine of theta is equal to root 10 over 10. Okay, root 10 times root 10 is 10. Now the next thing that I would find is the reciprocal. So the reciprocal of sine is the cosecant. When you do the reciprocal though, if you were to do the reciprocal of your final, and you can just watch me with this because I'm going to show you a better way. Okay, when you do the reciprocal, you would end up with a radical in the denominator again. And if you ended up with a radical in the denominator again, then we'd have to rationalize, and you'd have 10 root 10 over 10, and then what would happen here? Yep, you would end up with the square root of 10. So instead of doing this, if you just look at the first step that you have here, just flip this fraction. Because see how you have 3 root 10 over 3 if you flip it? And then when you reduce, all you have to do is cancel out the 3's. And you would be left with the cosecant is equal to root 10. So see how that's a little bit quicker? Now, could you do it the other way? Yes. Do you have to? Nope. You can do it like I showed you. All right. So based on that, can you guys do the cosecant? And then the cosine? Just do the cosecant. The cosine, the tangent, and the reciprocal. Okay, do we need more time for the cosine, or are we feeling good? Okay, so you had 9 over 3 root 10, and then just like we did before, we're going to reduce. So 3 goes into itself 1 time, 3 goes into 9 3 times, and then I still need to multiply. So that in the denominator, I have a whole number. And then in the numerator, we're just going to leave this as 3 root 10. There's nothing else I can simplify there. Okay, so we are going to leave that. And for the secant, again, I recommend that you take this first fraction here, 3 root 10 over 9, and reduce. 3/9 reduces to 1/3. So the secant of theta would be root 10 over 3. All right, and last but not least is our tangent value. So our tangent is the opposite over the adjacent, which is 3/9. That reduces to 1/3. And when you guys just make sure that you have your theta values, and then your cotangent, what's the reciprocal of 1/3? Yep, 9 over 3, which would be 1/3. All right, nice work. in example 2, it says, in a right triangle, A and B are acute. We are going to find the exact values of the 5 remaining trigonometric functions. So they give you one trig function, you have to find the other based on this information. So instead of using theta, they are telling you that this cosine is of angle A. And what I like to do, because I'm pretty visual, is I like to draw my triangle. You can draw any right triangle. This is my favorite one. And then I'm just going to label this A, B, C. Okay, so if it's the cosine of A, this is the angle that we're using. And if it's the cosine, I know cosine is the adjacent over the hypotenuse. So right away, I know my hypotenuse value is 10, and I know that my value of the adjacent side to the angle is 3. And then I can just call this unknown value, like lowercase a. Again, generally, if you have A here, capital A, lowercase a is next to it, but you are going to be using the Pythagorean theorem to solve. So we know a squared plus 3 squared equals 10 squared, okay, or a squared plus 9 equals 100. So when we subtract 9 from both sides, we're left with a squared is equal to what? 91. Okay, and then we take the square root, we can reject the negative answer, and we are going to leave this as the square root of 91 because there are no perfect squares that go into 91. It's not even, so 2, 4, 16, none of those will go in there. 3 doesn't go in there because 9 plus 1 is 10. Okay, so your value for A is root 91. So now I can find my sine, and this time it's of A. Okay, so everything is going to be in terms of A. So the sine is the adjacent over the hypotenuse. So remember, sine is the opposite over the hypotenuse. Remember that we did A and H, so this one is O. Okay, so the opposite side is root 91 over 10. We already have the cosine, so I'm going to do the tangent. The tangent is the opposite over the adjacent, which is just root 91 over 3. Okay, and then I'm going to start doing my reciprocal functions. So for the sine of A, I have root 91 over 10. So if I were to flip it, if I were to do 10 over root 91, I would have to rationalize to get 10 root 91 over 91. That is going to be the cosecant. That's the reciprocal of your sine value. Okay, if you want, you can do your reciprocal of tangent next. So if you did 3 over root 91, you're just going to multiply the top and the bottom by root 91. So your cotangent is 3 root 91 divided by 91. Remember, 3 does not go into 91. Okay, and then we have to find 5. So they gave you cosine. You just have to flip that to find your secant. So your secant of theta is 10 thirds. So it's the reciprocal of cosine. So 1, 2, 3, 4, 5. Okay, I'm going to help you set up part B, and then I will have you find your values. So the tangent of B is equal to 2. You always want a ratio. If it's a whole number, that just means it's 2/1. So tangent is opposite over adjacent. So again, we're going to set up triangle ABC. And this time we're doing angle B. And then see if you can set that up and find all 5 of those trig functions. If you get some trouble getting started, I always start with setting up the opposite over the adjacent. So if my opposite is 2, then it's going to be across the circle. And then 1 is the adjacent side. And we don't know what the hypotenuse is right now. We can call it C. So we have 1 squared plus 2 squared equals C squared. And it's okay if it's not a whole number. Okay, you're going to run into that. So this is 1 plus 4 equals C squared. Okay, so your hypotenuse value is the square root of 5. And when you guys are showing your work, I know that you're familiar with the Pythagorean theorem. If you just want to do like the 1 plus 4 and then the square root, that is fine. Okay, and then we are ready to do the sine. Another thing I think is helpful is if this is my angle, I'm going to label this as my opposite side. This is my hypotenuse. And then this is my adjacent. Okay, so that I can use my silver color. So your sine of theta, or sorry, not theta. Did I do that on this one? Change these to A. So this should be the cotangent of A and then the secant of A. I just love theta so much. And this should be the sine of what? If it's the tangent of B, this will be the sine of B. Okay, so if I do the opposite, I have 2 over root 5. We just don't want to leave it with a radical in the denominator, so we're going to rationalize. Okay, so the sine of B is 2 root 5 over 5. Now, like I did earlier with the square roots, I really do think it's helpful if you do the flip next, because you can take this value, 2 over root 5, and you can just do the reciprocal. So we started with 2 over root 5, save. If you flip it, you will have root 5 over 2. Remember, those are the reciprocal functions. Okay, now we're going to do the cosine of B. So it's the adjacent over the hypotenuse. Just like we did before, we are going to rationalize, which will give us root 5 over 5. So it's the cosine of B is equal to root 5 over 5. Okay, and then we're going to flip this. So the secant of B, if I had 1 over root 5, it would be root 5 over 1. What is anything divided by 1 equal? Itself. So it's just going to be root 5. Okay, and they gave you the tangent, so all you have to do is find the cotangent. So if it's 2 over 1, the cotangent is 1/2. 1 over 2, yes, yes. All right, is some of the sine, cosine tangent coming back to you now? Okay, so the next thing we're going to do, this should be brand new. Okay, what we're going to do in upcoming sessions is we're going to have to pay attention to quadrants, and this is going to lay some of the groundwork for that. So in example 3, they give you point P, and this is a point that's on the terminal side of theta in standard position. Remember, standard position just means that you have your vertex at the center, okay, you have your initial side, and you have your terminal side. Again, we are finding the exact value, and we've seen that term a lot in the directions today. Do you guys remember what an exact value is or isn't? Yes, it's not a rounded decimal. Okay, so not rounded. No decimals allowed. Okay, so you will have your radicals there. Okay, and we're going to find the exact value of the 6 trig functions here for theta. So here I wrote out your theta. That's what yours should look like when you are writing those out on your homework. Okay, and again, just like we're showing work on our notes, that's what we're going to do on our homework as well. Now, when you are starting this example, what we want to do is we want to plot this on a grid. Okay, so we are going to plot this point, and I'm going to go by 3s here. Okay, so on the y's I have to go up to 9, so I'm going to go by 3s. Okay, and then I have to go out to 6 there. I'm going to go by 3s here as well. They're both multiples of 3. So this would be -3, -6, so on and so forth. Alright, so this point would be right -6 of 9. This is point P. And what you have is this terminal side here. What we're going to do is create a triangle from this. Okay, so we're going to create a right triangle. Okay, and you may have done some creation of right triangles before. So if I extend this straight down to my axis and use this as my axis, my theta value is right here. This is your theta. Okay, this creates a right triangle. I'm going to take this and I'm going to draw this here just to give you guys a better visual. This is point P. This is theta. Okay, because we're going to do some Pythagorean theorem stuff here. So based on this point, we can label the sides, and this, bless you, and this time your signs are going to matter. So the distance here from 0 to negative 6, we are going to label this as negative 6. Okay, so again, if it's a negative, you are going to use that. Okay, so it's 6 units to the left, which is a negative 6, and then from 0 to P is a 9 units. And just like we did above, we are going to have to solve to find C. Okay, and what are we going to use to do that? Pythagorean theorem. So we have 9 squared plus negative 6 squared equals C squared. Okay, we're going to do that without a calculator. So we're going to review a few no calculator concepts. So 9 squared is 81, negative 6 squared, 36. Okay, when I add 1 and 6, I get 7. 8 and 3 is 11. Okay, now, we do have to make sure there's no perfect squares in 117. Generally, I check 2 and 3 first. 2 doesn't go into an odd number, but how do I know 3 goes in there? Yes, 1 plus 1 plus 7 is going to be 9. So I'm going to factor tree this. So I know 3 goes in there. I might have to rely on my long division skills. 3 goes into 11 3 times. Subtract. 3 goes into 27 9 times. Okay, what's the factor that goes into 39? 3 times 13. So remember, in a square root, if there's 2 of them, it goes on the outside. Root 13 is left on the inside. So C is equal to 3 root 13. Okay, once you have that, now you are ready to do your trig functions, but you do have to include the negative, so just don't forget that part. That's the part that's new from what we've done before. So we're going to start with the sine. Theta is always going to be with your x-axis and the terminal side. Okay, so you're going to have different points, different quadrants that you have. Okay, theta is always going to be with the x-axis and the terminal side. So if you had something in a triangle in quadrant 1, the x-axis and the terminal side is here. That's where your theta would be. If it's in quadrant 2, that's what we just did. Terminal side, theta. Here, terminal side, theta. Okay, I like to remember it looks like a nice little bow tie. Okay, so that's for other points that you may do. So once you know where theta is, now you can do the opposite, the adjacent, and the hypotenuse. We have the hypotenuse here. Our opposite is 9. Our adjacent is negative 6. So the SO is 9 over 3 root 13. Okay, you can go ahead and simplify that. Okay, so 3 goes into itself once, goes into 9 3 times, and then you are going to have to rationalize. So for the sine, you're going to have 3 root 13 on top divided by, what's root 13 times root 13? 13. Okay, from there, I would do the cosecant, because the cosecant is just going to be this guy flipped over. And 3 goes into itself once and 9 3 times. So the cosecant is root 13 divided by 3. cosine next. Okay, so cosine, you have your adjacent over the hypotenuse. Okay, so 3 goes into itself once, goes into 6 twice, and then we have to rationalize. Don't forget the negative here. So it's a -2 root 13 divided by 13. Root 13 multiplied by itself is going to be 13. Okay, and we can go ahead and flip it for this secant. So it's a -3 root 13 over 6. The negative, it doesn't matter if you put it on the top or the bottom here, but this is going to reduce to negative root 13 divided by 2. Or you can put the negative on the bottom, that is fine. Okay, the tangent is the simplest one of this group, because you're going to do the opposite over the adjacent. What goes into both 9 and 6? 3. So if I divide by 3, I'm going to get 3 over -2. Again, that negative can go on the top or the bottom or the outside. And then when you flip it for the cotangent, just use the reduced version. Okay? Alright, so remember, your homework is mandatory due by 7:40 a.m. tomorrow. Make sure you follow your directions. Make sure you show your work if you want full credit.